All right, so our learning target, again, like I said, I can use slope and similar triangles to determine if a point is on a line. So when we are talking about slope, the first thing that I want to do is just kind of review over what we covered last semester with slope. The only covering that we had on slope last semester were the types of slopes. So we had 4 types of slope, and they were displayed in that video by Slope Dude where he was going on a skiing trip. And when he first started his skiing trip, he was going uphill, and it was a very difficult thing to do because, you know, you're going uphill on skis. And so he was puff, puff, positive, puff, puff, positive. So this is the idea of what a positive slope looks like. From left to right, it's moving in an upward direction. And then we had the idea of that nice negative, that negative slope, which was a really nice and easy run. Once he got to the top of the hill, he was able to go downhill, and it was nice and easy. So nice negative. Okay, so from left to right, if a downward slope, that is a negative slope. Then he got to the part where he said it was zero fun, which was that that horizontal line. That horizontal line is creating that idea of a zero fun concept, or a zero slope. And then our last one is when he fell off the cliff and started yelling undefined. So undefined is that vertical line that we create. Okay, so those are the 4 types of slopes that we learned about. Now we're going to actually talk about what slope means and how you are able to find slope. So the first thing that we're going to be talking about is connecting it with similar triangles. And the idea is that no matter where you draw a triangle, a right triangle on a line, whether you go from the origin to point A, or maybe you draw one from the origin to point B, or from point A to point B, they're all going to have the exact same slope. And what slope represents is the concept of what we call rise over run. So right over here, I want you guys to write slope equals, and you're going to draw a little fraction bar. And that fraction bar is going to have rise on the top, which is the value that goes up if it's increasing, or down for decreasing. And then in your denominator, we have our run, which happens to move left to right. Moving to the left would be a negative value. Moving to the right would be a positive value. Okay, so we're getting those ideas for our slope. From here, what we want to do is we want to first identify what the slope is, and then using some of these characteristics of the slope, we're going to find what the values are for each of these points that we have graphed here. Okay? Sorry. So we're first going to start off with identifying our slope. So like I said before, our slope can be found by taking the rise over the run. Now, your rise is the value that moves up and down. Your run is the value that's moving left and right. So we actually happen to have, based off of these 2 triangles that they've created here, we happen to have 2 values for our rise and 2 values for our run. So those 2 values that I have for my rise, I have a rise of 3, but I also have a rise of 6. So both of these are considered to be a rise value. So I could put 3 on the top, or I could put 6 on the top. And then I have runs. I have a run of 4 and a run of 8. Now, just like we said before with with similar figures, you have to have corresponding measurements. So this 4 corresponds or belongs with which one of these rises, the 3 or the 6? The 3. Okay, so we're going to put the 4 underneath the value of 3. And then what's going to go underneath the value for 6? The 8, because that 8 is going to correspond to the rise that's the 6. Okay, now the nice thing about this is that because they are on the same line, they are equal to each other. In fact, if you simplify 6 over 8, you're going to get 3/4. So your slope, no matter which points you pick, will come out the same. In fact, I could do another one. If I wanted to do another rise, I could do a rise that was right here, connecting to a run right here. So I could just do one gigantic triangle that has a rise of, what do you think? What do you think this rise is? 9. Let's see, if we have 3 and then we have a 6, 3 and 6 is going to create that 9. Okay, and then what do you think the run is going to be? 12, right? If we have 4 and then another 8, that whole thing together is 12. And if we were to put that as a slope, if we did that as a slope, that would be 9 over 12. And wouldn't you know it, it comes out to the same thing. It still comes out to 3 over 4. Okay, so it does not matter where you pick your 2 points to be. When you connect them, they're going to create a proportional or a similar right triangle. They're going to create these series of similar right triangles that all have the exact same identical slope. Okay, and slope, guys, slope is just direction. Slope is just a direction. It tells you how to get from one point to the next point. So for here, if we're trying to identify what these coordinates happen to be, the first thing I need to understand is, where did I start? When I started my graph, what point did I actually happen to start at? What point is this right here, guys? 0, right? This point is my origin. I happen to be passing through the origin. This point is 0, 0. So I happen to be starting at 0, 0. And just so you know, all coordinates are always written as x, comma, y. Your x value always gets written first. Your y value always gets written second, right? So when we're taking a look here, the cool thing about our rise and our run, the run has an effect on the x value. You can either add or subtract your run to your x value. And with your rise, you can either add or subtract your rise to your y value, and it'll allow you to find your next point. So if we know that we're starting at 0, 0, and then I did a rise of 3 and a run of 4, then I can go ahead and say, hey, I'm going to add 4 to my x, and I'm going to add 3 to my y, and that's going to get me to my next point, point A. So the coordinates for point A are 4, 3. Now, my next set of rise and run is not starting at 0, 0, is it? Where did it start at this time? 4 and 3. So from 4 and 3, I'm going to then go ahead and add on my rise and my run to my coordinates to find my next point. So what am I going to add to the x value to get to my next point?
4.
Well, was this a 4?
6 and 8.
The 6 and 8, but which one is it going to be, 8 or 6?
8.
8, right? The run affects your x. So in this case, this run happened to be an 8. So we're going to add 8, and that gives us 12. Good. Then to our y coordinate, we're going to add this rise. That rise was a 6, and that's going to give us 9. So point B happens to be at the coordinates 12, 9, which makes sense, because if we started at 0, 0, we went up 9 for our rise and to the right 12 for our run, so 12, 9. Now, not always. So here's the only thing. The reason why our rise and our runs happen to be part of the actual points is because we started at what original point? 0, 0. Do you think every single graph is going to start at 0, 0? No. You're going to have some times where the graph starts at a different point, but you can still do the same thing. You can still add your rise to your y. You can still add your run to your x, and it'll take you to your next point. So let's go ahead and take a look at the next one. So here, again, we want to find our slope first. Always start off by finding your slope. So they, again, started at the point 0, 0. Point A started at 0, 0. And then they're going on up to point B. So we need to identify the rise and the run. The rise is the movement up and down. So that's going to be this movement right here in my pink. The run is the movement left and right. So that's going to be what I'm highlighting here in the blue. So who can raise their hand and tell me what is the run? How much did we move for our run, Jackson? 4. So our run happens to be a positive 4 because we moved to the right. We moved to the right. And then what about our rise? Who can raise their hand and tell me what the rise is going to be? Ryan? 3. Positive 3. It happens to be a positive 3 because we had to then move up. It's very important to understand positives and negatives because sometimes you might move up and then to the left, or you might move down and then to the right, and that would create a negative value. Okay? So when we are identifying our slope again is whatever our rise value is going to be, which is a positive 3, over our run value, which happens to be a positive 4, and that's just going to come out to 3/4. So there's our rise and our run. So now we want to know, is the point 2015 going to be a part of this line? So I can't see where the point 2015 is going to be. It's off of my grid. So I can't actually visualize it here on my graph. I'm going to have to use what I know about slope to see whether this would come out to being a point on there. So one of the things that I know is I went from 0 to this point, and this point happens to be 4, 3. I know I used a rise and a run to get from 0, 0 to 4, 3. So now I want to know, am I going to be able to create a similar or a scaled version of my slope to get from 4, 3 to 2015? So let's start with 4, 3 first. We're going to start with 4, 3. And what we want to do is we want to get to the point 2015. So I need to figure out what was the rise and run that took me from 4, 3 to 2015. Let's start with the run first. What run would take me from 4 to 20? Juju? We're not multiplying here. Remember, we're increasing or decreasing, which means we are either adding or subtracting the entire time. So what are we adding or subtracting from 4 to get to 20? Juju? Plus 16. Good. So it's a positive 16 that takes us from a 4 to a 20. What about my rise? I went from a 3 to a 15. What took me from 3 to 15? EJ?
Plus 12.
Plus 12. So again, it's a positive 12. So now we need to check, is that the same exact slope? Will it simplify to 3 over 4? So we always put our rise on the top, which was the 12. We're going to put the run on the bottom, which was 16. And then we're going to simplify. 12 over 16 simplifies to 3/4. So yes, this is a point on the same line. We are able to create a point on the exact same line. So now let's check this point, 90, 68. Do you think I need to use 4, 3, or can I use 2015?
2015.
I can use 2015. I could use 4, 3 as well, but 2015 is a little bit larger of a point, so maybe I want to go ahead and start with that one. So we're going to start with the last point we had, that 2015. But again, you could use the 4, 3, or you could use the 0, 0. Either of those are fine because they're all points on the same line. And we want to see how can we end at 90, 68. We want to end at 90, 68. So we're going to check, what does our run have to be? Is our run going to increase or decrease? Increase by what? By 70. Good. Our run is going to increase by 70. Okay, and then what about our rise? Is our rise going to increase or decrease? Increase. And what is it going to increase by to get from 15 to 68? 53. Good. Not negative, positive. It went up, right? So it's a positive 53. All right, now if I put that into my calculator, 53 over 70, is that going to simplify to 3/4?
Yeah.
No.
What?
It's just going to stay 53 over 70. Okay, so no, this is not a point on the same line. It does not have the same slope. So that's not the same slope. If it's not the same slope, then it is not along the same line. Okay, I want you guys to try the next problem on the back on your own. Okay, the first thing that we need to do with this problem is we need to identify what the slope is. So we're going to identify our slope by, again, finding our rise over our run. So for the rise, our rise happens to be a value of 3. So we'll put that rise is equal to a positive 3. Our run happens to be that positive 6. So run is equal to 6. And then like always, you want to be able to simplify it. Simplifies to 1/2. So your slope in this situation is going to be 1/2. We want to know, does the point 2040 lie on that line? So we're going to pick one of these points and see if us going to from that point to 2040 is going to create a slope of 1/2. It doesn't matter which point you pick. It doesn't matter at all. In fact, I'll just go ahead and pick the 10, 9. So let's say that we started at 10, 9. And again, we want to get to the point 20, 40. So that means that we'd have to have a run that is increasing by 10. So we would have a run that is a positive 10. And then our rise would have to increase by 31 in order for it to get from 9 to the 40. It has to go up by 31. So our rise would be a positive 31. Is 31 over 10 the same thing as 1/2? No. That's going to simplify still as 31 over the 10. That's not the same. Not the same slope. So therefore, this is not a point on that graph. It's not going to be a point on that line. Now what we do want to know is if the point x20 falls on this line, then what does the value of x have to be in order to create a slope of 1/2? Okay, so I know that I have that point 10, 9. I know that my rise is going to have to increase by something. I know that my, sorry, not my rise, my run, that should say my run. I know that my rise is going to have to increase by something. And what I'm wanting to end up at is some value of x and then the value 20. Okay. So my rise wound up increasing by 11. because 9 plus 11 gives me that 20. So now I need to create a fraction that's going to be equivalent to 1 over 2. So 11 over what will come out to 1 over 2? Very good. 11 over 22 would come out to 1 over 2. So that means my run has to be 22. So if I do 10 plus 22, that's going to give me my value for x. What is x going to have to equal? 32. 32 for my value of x. Okay, so the point 32, 20 is going to be on that line. Okay, we're going to go ahead and just do part A for this last one, determine the slope of the line. So taking a look at this given line here, we want to find the rise over the run. So here's my rise is connecting, moving vertical. My run moves my horizontal. What is my rise? How much am I increasing by? 1, 2, 3, 4. My rise is a 4. What's my run? 3. Okay, my run is going to be a 3. So that means that my slope is just 4/3. My slope is going to be 4/3. So what I want you guys to do is tell me, is 21 over 30 or 21/31, is it going to be on this point or on this graph? Go ahead and do that real quick. All right, taking one of these points, I'm going to take the point 6, 11. Shh, quiet. I'm going to take the point 6, 11. I want to go to the point 21, 31. So I need to check to see my rise. My run. We're going to do my run first. To get from 6 to 21, that means I'm increasing by 15. So that means I have a run of 15. Shh, quiet, boys. And then my rise goes from 11 to 31. That means I'm going to increase by 20. 11 plus 20 gives me that 31. So I get 20 over 15. If I simplify this, they're both divisible by 5. That would come out to 4/3. So yes, it's the same slope. Same slope. That means it is on the same line. Okay, go ahead and pack up.